Good day, engineering thinkers. Welcome to Engineering Thinking by IK. My name is Sean, and it's my pleasure and delight to be your host for this program today. The purpose of this show, since it's our very first episode, is actually to inspire and encourage all of you to think and act like an engineer. Whether you're in training to become one, or if you're just interested in the field, you have a place here with us. Today, for our inaugural episode, we have a fantastic guest lined up for you. He's the Managing Director and CEO of the Intrix Group. Along with his team of engineers, his company has secured 19 internationally accredited patents, and some of those patents have been commercialized and then implemented in prestigious projects, such as the London Olympics. He's also the current Malaysia chapter president of ASHRAE, and he's also chaired several expert committees within CIRIM and also the Department of Standards Malaysia. It's my great pleasure to introduce Mr. T. Tone Vei onto the show. Mr. T, thank you very much for joining us on the show today.
You're much welcome.
So for the first section of the program, we're going to outline Mr. T's hero's journey. We believe our engineers are heroes. And like any good superhero film, there's a start to every saga. So we're going to ask Mr. T, can you tell us who or what inspired you to become an engineer?
My family, my uncles, they were all engineers. So I grown up in an engineering family. My father is not an engineer, but all my uncles are engineers. Growing up in their workshop, playing around with soldering iron and all kind of engineering toy, I call it. Yeah. I remember when I was in high school, my father took me to this invention exhibition. I remember it's in University Malaya's one of the hall. And I was so inspired how people can create things. So from there on, I have made up my mind that I wanted to be an engineer. Yeah.
Fantastic. Yeah. And can you tell us a little bit about your training to become an engineer, where you studied or how you got to where you are today?
I think my training comes from two areas again. Since high school, I've been working in my uncle's workshop. So I get to learn all kind of things. Who one of the young engineers sit beside me, going through a catalog and ask him one by one what this is. And I think that built some of my fundamental knowledge. And of course, then I went through a formal education, study electrical engineering in the United States. Yeah.
So when you were in the United States studying engineering, did you come across any sort of challenges or difficulties as you were learning the craft?
Yeah, I love the subjects I love. I hate the subjects that I don't need. Okay, but in the university education, you need to be holistic. So there are subjects that I deem to be not so useful, but I have to suffer through it.
So you still persevered through it anyway?
Of course, otherwise I can't graduate. Right? Yeah.
So was that part of the drive that kept you on the path of engineering, even though you sort of had subjects back in the States that you weren't very keen on, but you still tried your best because you felt motivated to finish the course?
Okay, to be very simple, at that time I just wanted to graduate. Okay, and then I was so eager to go into the real engineering world, to start working, start creating things. So, but I know I need to go through the formal education to learn things I want to learn, including things I don't want to learn, so that I can leave university. But you never know, I remember my study years. Number one, I hate semiconductor, and I don't like high power electrical because I was aiming at electronics engineering. And I had to take thermodynamics. So I was thinking, I'm an electronic engineer, why thermodynamics? Okay, then my first job is in one of the largest semiconductor company. My second job, dealing a high power electrical all the time. And for the last 30 years now, I spend most of my time in thermodynamics. When I go to university, I will be talking about thermodynamics topic. So you never know during your study what's actually useful or what is actually not. Yeah.
So it's a good blessing that you stuck with it and really persevered and stayed on the path then.
Yeah.
So can you tell us a little bit, since you mentioned thermodynamics, and I know Intrix, along with many of your patents, can you tell us how, as an engineer, you founded Intrix and went towards business side of things as well?
Right. So As I said, my first job is in one of the largest American semiconductor company, and I got bored actually because there are too many engineers and our hands are too tight. We can't create things. And I was sort of quite a rebellious engineer. I want to sort of challenge the norm. Yeah. So then I went to a smaller company. I got a chance to set up an R&D department, and then set up laboratories and everything that interests me. So 13 years in the company. Eventually, I went in as an engineer. I left as a GM of 4 factories with the R&D departments and things. But along my 13 years career, I felt that and this R&D is really something that I'm very interested at. So I then decided to set up a design consultancy firm. Yeah. That's how I started the predecessor of Intrix. We call it Thermal Hydro Consultants, which is a bit boring name. Temperature and humidity and water. We try to design product that simplify people's life. Okay. As a design consultancy firm in Malaysia, we couldn't find a client willing to pay our fee. It was whoever we quoted to, they will complain that it's too expensive compared to other draftmen and all things. So we know that was back 20 years ago. The intellectual property has not been really given a proper value. Okay. Then we decided, why don't we go to countries where they will pay for intellectual property? And then because of previous contact, so we started our first business approach in the UK. After about a year, we got a first project, and very fortunate first project. It was UK's largest water heating company, and we designed a product for them. And from there on, we worked more and more in the UK. And then our second customer is the Germany's largest water heating company. From there on, we probably spent about 10 years doing projects in the UK. Don't get me wrong, we are based in Malaysia, Malaysian engineers, proudly Malaysian engineers, but we are providing engineering solution, R&D solutions to UK and Germany.
Okay, engineering thinkers, we're now in our second section of our program for today, and it's going to be the highlight. And during this portion of the show, we're going to have our guest, Mr. T, share with us some of his experiences in projects that he's contributed to or led. This way, all of us can learn what real engineering looks like when applied in industry. Now, Mr. T, could you please share with us a story or case study that you were a part of?
Our design scope actually covers very wide spectrum. From the far end of the largest size, we built systems, hot water systems, centralized hot water systems for the world's largest hotel. On the other far end, we built small, tiny heating and water purification system for home. So which one would you like me to share?
Let's start from the smaller one first and see, and build towards the bigger one.
Okay. The smallest one is one of our flagship products. It's called One Tap. So this is a small unit of command center, we call it, but it's a water purifier with heating capability. Small and neatly hidden below the kitchen cabinet. Okay, and above the sink, there's a water tap. So the water tap will dispense drinking water, purified drinking water, hot boiling water, which is about 98 degrees Celsius, up to 98 degrees Celsius. One tap will be multiple functions, particularly drinking, cooking, washing, sterilizing, all in one tap. Yeah. Now, if you look at Malaysia market, when you look at water purifier, all the water purifier is above the countertop, right? These days, the homes are smaller and smaller, kitchens are smaller and smaller. We have this countertop we call a worktop. It's not supposed to be a storage top. Okay? And we have a kitchen sink. We left very little space for working. And if you put a water purifier up there, number one, it takes up about 20 to 30% of worktop space. And number two is, if you look at the trend now, everybody going for minimalist design, also conceal integrated design in the kitchen. So when you look at a kitchen, we now won't have a standalone microwave oven, standalone ovens or dishwasher. Everything is built into the kitchen cabinet. One of the last major appliances that's still sitting on top of the countertop is the water purifier. So we've been thinking, how do we solve this problem? At Intrix, one of our philosophy is fulfilling undiscovered needs. The needs that the user don't even know they have. Okay. So people taking for granted that water purifier will take up the space, but basically they actually need the space. Okay. So we came up with a solution to put a water purifier underneath. And in every kitchen, there's a tap anyway. And the tap is dispensing water. So why don't we dispense purified water through the tap? And because we are from thermodynamics background, so we also designed with a heating capability. And if we want to heat it hot enough then. Because our first target market was in the UK. If you look at a typical water purifier, whatever the display shows, it can only dispense about 80, 85 degrees C hot water. And in the UK, where British likes this English tea, right? English tea, you need to be more than 90 degrees C and above to bring up the aroma. So the British will call hot water that below 90 degrees C, they call it lukewarm. They don't call it hot water. So if we are capable to design it, then why don't we design it hot enough? So we design it to 98 degrees Celsius. In this case, then it's not only making tea. At 98 degrees Celsius, we can actually blanch vegetable. We can soften pasta. We can pre-cook a lot of food. And we can use it to sterilize milk water. And it become, from an original idea of water purifier, now it became a kitchen aid. It's a multifunctional kitchen aid. Now, of course, now we talk about engineering. What was our challenges? First of all, maintenance is a problem. With a lot of water purifier, it requires maintenance every 3 months, every 6 months, and other things. These days, who has time, right? So when we're talking about our philosophy to simplify people's life, so the proper product should be fit and forget. So what we need to do is remove the maintenance element as much as possible, and that inspire us to invent a heating system, heating coil using titanium. And we are the only one in the world, because we patented it, of course, only one in the world that uses titanium. Titanium is a metal that is totally biocompatible. It's corrosion resistant, so we won't be worried about limescale and all kind of corrosion. So that makes it maintenance free. And the next thing we think about is sustainability today, right? Water purifier today typically change one cartridge every 3 months, the other 2 cartridges every 6 months and all things. So all in all, in 1 year, typically they need to change 6 to 7 cartridges. And all these 6 to 7 cartridges ended up in the landfill. In Malaysia alone, we have more than 10 million cartridges to the landfill every year. Now, because people have this myth, they think that more cartridges means cleaner. Of course, more cartridges means multiple stages. Okay, but if you open up those filter cartridges, most of them are quite hollow inside. Okay. So what we are thinking is, why don't we reduce the use of plastic, but putting the multiple stages into one cartridge? So our cartridge, and then put in more material so that it lasts longer. So our cartridge so we came out with a solution that we only use one cartridge and can be used for 1 whole year. We reduced the waste to the landfill by 85%. Okay, so those are the few things that we do with one tap, and fortunately the market received it well. Okay.
So can I ask you, Mr. T, since you talked about one tap, you talked about addressing the local needs, because it's based out of UK to begin with, right?
Yeah.
And you said that anything below 90 degrees Celsius is considered lukewarm. Actually, it's inappropriate for British tea, right? But there's also a lot of design elements when you talk about engineering, not just in materials engineering when you mentioned the titanium, which was obviously a very good choice. But how was it like for you and your team of engineers to look at the design elements as well, especially to conceal it underneath the kitchen counter? What was that process like for you to sort of marry the concepts of engineering and design?
Okay, so before you design a product, basically we have to have an insight of what market needs. A lot of inventors made a mistake by designing something, then only go to try to find where the market is. Okay, so it should be reversed. We have to have an insight of where the market is, then we design or invent the product. But the key thing is, if your product is so disruptive, you can't go ask the consumer what they want. Just like Steve Jobs says, the consumer won't know what they want until you show it to them. Okay, so the designer or the product strategist will have to have the insight of what are the undiscovered needs in the market. And this one, we happen to have the insight that the countertop is something that people need to use it as a worktop. Okay, and also we feel almost every home we go in with a modern kitchen, everything is so well nicely integrated except that ugly blocks up there. So that prompts us to think we want to solve the problem.
Engineering thinkers, so we just heard from Mr. T regarding the one-tap solution. And now Mr. T is going to share with us one of the bigger projects he was involved in. Mr. T, if you'd please share the background of this next project with us.
Right. This next project is Genting Highlands First World Hotel. You know, First World Hotel is the world's largest hotel. They had 2 blocks, 2 towers built long ago. The centralized hot water system was fueled by diesel. Of course, everyone nowadays are going towards decarbonization, going towards ESG. So, but that was 10 years ago. Genting has a vision to, when they extend the tower 3, we call it 1 tower, but it's actually 1,300 rooms. It's 4 times to 5-6 times larger than any typical hotels down here. So it's still huge. And they wanted to try something that probably more, we call it clean energy. Some hotels down here at the ground level, we've been using heat pump. It's a technology that harvests heat from ambient air into hot water. But because we harvest heat, we do not generate heat. We harvest heat, but of course we have to put in a little bit of energy to help to harvest it. Still, we can save up to 75% of energy and reduce carbon emission by 75%. So, but Genting is pretty cool. For many years, they thought there's not much heat to be harvested. So no one actually used a heat pump solutions up there. And they asked us if we want to try. We've been doing projects in the UK. The UK is about as low as 5 degrees C and below. So 15 degrees C in Genting, I think quite comfortable for us. So we thought we want to challenge this. Eventually, we built a large system for them to supply hot water for 1,300 rooms. And how big is the system? The heat pump equipment itself is like a 20-feet container, 6 units of them. And then another 12 units of a hot water storage tank. Each one is like a tanker on the road that you can see, about 12 units of them that will be powered to supply 1,300 rooms. But even with the colder weather in Genting, we managed to save energy and carbon emission by 70% compared to traditional diesel. So this project has made us the largest renewable energy hot water system in Southeast Asia. And there is no Southeast Asia Book of Records, so we can only get Malaysia Book of Records. But what is more, what we feel as engineer, we feel more prestige by recognized by engineering community. So this award has won ASTRA's Regional Technology Award, which is one of the most prestigious awards in this area. Yeah. So when we do project like this, it's unlike the previous example. When we build a product and mass produce a product, we have chance to produce iteration 1, iteration 2, go to test in the lab, field trial in consumers' house, volunteers' house before we launch it to the market. A project like this, basically a system in a construction site. Those systems are placed on top of the hotel roof. When the hotel finished construction and the tower crane is removed, we can't access that anymore. So we have only one chance to get it right. Whatever we design and place up there, when the hotel is ready to start, we switch on, it must work. Okay, we have no chance to replace it because there's no more tower crane. So in order to do that, the project management is most important. And second thing is, in most of construction projects, the timeline also is very important, and there will be some penalty clause if we don't deliver on time. So again, come back to project management. So of course, the first thing I have to do is to select a reliable project manager. And this lady is very amazing. She was 8 months pregnant, and you can see her walking around in a construction site, making sure everything is on schedule, everything is well placed. Project like this, not only a good project manager, but we also need someone who is very good in communications, because we are going to coordinate with multiple parties. Apart from our own subcontractors, we have to deal with electrical contractors, plumbing contractors, building contractors, safety officers, and logistic control and all things. So the coordination requires enormous human skill. communications, and precision. These are the few things that needed in order to implement a project like this smoothly.
What were some of the challenges you faced, maybe logistics-wise, putting it all together actually at Genting itself?
Logistics was a major problem. That particular hotel not only is tall, it's at the edge of a mountain. So to crane up the equipment, we are not from the ground level. We are from about 8 or 10 floors below ground before we can crane up the things. You can imagine that logistic craning up is one of the biggest challenge for us. There's a lot of engineering calculations designed to make sure we can crane up safely. I mean, when you build a building, the drawing is always there, but actual implementation of drawing could be a bit out. So I remember one of the things when we tried to move through, on the drawing we designed the equipment with a bit of a clearance between the two pillars. By the time we reach a site, the pillar actually is closer. We can't go through. The pillar actually was off by several inches, which is quite common, but we were a bit naive. We were a bit naive at that time. So at the point we had to dismantle the equipment and construct certain part of the equipment on site to be able to pass through the pillars into the designated area. So there was some of the major challenge. But I describe it quite in a very simple word like this, but that actually cost us a whole lot of money.
Eventually, you did have the challenge, but you overcame it.
Of course.
Right, that's the important thing. This project happened 10 years ago, and,
Yeah.
and you said there was a bit of naivety there.
Yes.
And so, Mr. T, I'd like for you to share with our viewers and listeners, how would you have done it differently today now that you have 10 years more of that engineering wisdom and experience?
If we are not doing it differently today, then we have not been doing anything in the last 10 years. So in the last 10 years, of course, with a lot more experience, and we also evolve the equipment as a designer. Whenever we design some things, immediately when we deliver some things, I wouldn't say we don't like it anymore, but we already have an idea of what to do it better every time. So from that to now, we actually evolved 4 generations in terms of the equipment design now. In terms of equipment, we are now a lot more compact. Today, the equipment is half the size of what we used to do 10 years ago. So in terms of logistics, it will be a lot simpler. The second thing we also learn now, because we have the same challenge every high-rise building. Our latest project was 118. The Merdeka 118, our equipment is at 1134 and 1194 rooftop. Every time we have to deal with high-rise building, so it prompts us to think about how to overcome the logistic challenge. Yeah. So not only our equipment is a lot smaller now, but we are also designed in a more Lego type of a modular systems, so that we can break it down to smaller parts, but very quickly with very minimum work that we can integrate them together when we reach a rooftop. Yeah.
Okay, engineering thinkers, we've now reached the third and final portion of our program today, and the creative section is what we're going to call it. And in this section, we're looking towards the future of a field of engineering and also some lighter questions that we're going to ask Mr. T. Now, Mr. T, in this section, we look towards the future of engineering, and we have a lot of our listeners and viewers who might be in training to become engineers or are thinking of becoming an engineer.
Yes.
So what are some of the skills they should be picking up now in order to be successful in this field?
Okay. Apart from, of course, the engineering fundamentals, the engineering knowledge, I think to be successful in any field for engineer, number one is communication skill. I think so often that we have a lot of idea, but we can't sell it out. So the important part is how do we break down a complex situations into a simplified structure way that we can communicate and deliver to the listener, to the other party. I think this is one of the skills everyone, especially engineers, need to learn. And one caution is that when we talk to non-engineers, please talk in human language. Okay. A lot of time we talk in alien language that the other party will not be able to understand what we are trying to say, and they got bored. Yeah. Second gap for engineer that if we can balance out, it could be a bit better, is that most of engineers are thinkers. because we are trained to solve problems. We are trained to have a good analytical mindset. On the other side, we have to have a little bit of feeler in us so that we can be a bit more empathy and understand what other people's feeling. Some people born with it, but most of the engineers, not all, I'm trying to not to be totally stereotyping, but most of our engineers are thinkers. If we can be a little bit balanced on the other side, I think it will help us.
So we just covered the skills that people should pick up, obviously, and being more empathetic. You said it helps since a lot of engineers are more towards problem solving, isn't it?
Yeah.
Mr. T, you were recently in China for a conference, right? And I would like to ask you, when you were there at the forum in China, what were some of the key takeaways or some of the keynotes that were memorable to you that sort of look towards the future in the field of refrigeration and heating technology?
So the refrigeration world has been looking at, we have passed beyond comfort already. The refrigeration was originally designed or invented for two purposes. One is for comfort, one is to preserve food. Okay? But now that technology has been very, very matured. We have now passed beyond just for comfort. The whole refrigeration world now are talking about, yes, we want comfort, we want to preserve food. How can we do it with minimum energy consumption? So decarbonization is a key. Even ASTRAE, as a world's leading organization in this part, our theme this year is about decarbonization. In China, these few years, they have made a lot of transformation in this area. And I haven't been to China since pandemic, and for at least 4 or 5 years now. I can see a big leap forward towards this technology, and not just the technology, the whole awareness. The awareness of needing to reduce carbon emission, the awareness towards green energy, clean energy is almost in every manufacturer, everybody's mindset. That's what amazed me actually. So the technology advancement is all towards the area. And second area that's in the refrigeration world, everybody is looking at cooling side. But now people are starting to look at the heating side, because thermal energy contributing to 40% of carbon emission in the world. And so the world is pushing towards how do we heat efficiently? How do we heat with minimum carbon emission again? And this trip in China, I see a lot of new development in this area.
So that's very interesting. So you're telling me basically, as technology progresses, the industry or the field's finding more ways to use energy more efficiently. So to lower the cost of operating the equipment, but also being more efficient in the process of operating it. So what I want to ask you, Mr. T, was that while you were in China and you learned about some of these new breakthroughs, how did you interpret that about Malaysia, the current situation in Malaysia? Because there's a change now. There's a groundswell here in Malaysia moving towards smarter buildings and more energy efficient solutions. So when we talk about more efficient solutions, and Intrix is very much involved in this, what do you foresee for Malaysia?
As you know, the cabinet just passed the Energy Efficiency and Conservation Act. So definitely there's a sufficient push towards decarbonization. We have set a fairly aggressive targets to follow, to be aligned with the United Nations and the rest of the world, that we want to be net zero carbon emission by 2050. And we can't be doing what we are doing today and expecting to achieve that. There's a lot of aggressive actions needed. Is it sufficient? From what I see today, it's far from sufficient. Okay. A lot of talks, but the framework and the actions from the industry definitely is lacking behind. Okay. The awareness level is lacking behind. The motivational factor is lacking far behind. Today, our industry, I think majority of the consideration towards decarbonization are purely or largely only motivated by financial return. Okay. The ESG element has not been the major driving force on that yet. So I think it has to come from multiple areas, the educations, the consumer driving them, and also from the government legislation and incentives and multiple areas, multiple approach to move us forward. So this is one. Second part is a technology part. Malaysia traditionally and until now is not seen as a technology exporter. We are a technology importer. But importing technology means we have to, with our exchange rate, importing technology is expensive. In China, I've seen this. Personally, I was in contact with Beijing Tsinghua University and Shanghai Jiao Tong University. And I can see that research is a lot more industrial relevant. Okay. And the industrial to academic collaboration is not only very close, but also very practical. And this is a thing that we try to promote in Malaysia, where trying to close the gap between the industrial and the ivory tower. And the gap now is fairly wide. You hardly see amount of research from the academic side being commercialized by the private company or industry. And that gap, being a smaller market in Malaysia, private company has limited ability to fund into R&D, to fund the R&D. A lot of time, the good brain power is supposed to come from the universities, but there's a big gap between the two. Yeah.
What are some things that young graduates or young engineers can do to help shorten the gap? And what's something that the industry can do in Malaysia to catch up with the rest of the world in these terms?
Right. To the first question, actually I put a lot of hope to young engineers to help us push towards net zero 2050. We need to do things differently, right? If we're going to do the same way, we are not going to achieve the different result. And not only not going to achieve the different result, with the world population growth, we're going to consume a lot more energy. If we are not changing the way we consume energy, global warming definitely is already seeing the impact in many parts of the world, but it can only get worse, right? But younger engineers, fortunately, they are a lot more aware. They are a lot more conscious about this. Okay. Now, the next thing what we need them to be is be a little bit more rebellious, be a bit more daring to challenge a norm, be a bit more daring to try to break the limit and challenge the limit and design or invent or work on more innovative solutions to change the current practices. Yeah. And I think the younger engineers should be more rebellious than our generation. Our generation is a lot more compliant. Okay. Yeah.
And how about the industry? What can the industry as a whole currently do to sort of catch up with everyone else?
Yeah. The industry eventually have to catch up because the government has already set the vision, and the vision is not just Malaysia's vision, it's the world's vision and the need, not just vision, the need to go towards net zero carbon emission. The only question for the industry is, when are you going to catch up? The early birds will get the worm, or when is the right timing? Today everybody is looking at, do you go first or you go first? Okay, but I feel in next couple of years, after EECA has passed, next couple of years, like it or not, the industry will have to be pushed towards that. Whether you do it voluntarily, or the customer is pushing you, the world market is pushing you, or the government legislation is pushing you, or at least the energy cost is pushing you. So I feel for the industry, the earliest you get prepared, I think you will be in a better position.
All right, excellent. So now that we've established what the industry can do and what the individuals can do, Mr. T, now I've got a more lighthearted question for you in the creative section. Now, as the viewers and listeners know, Mr. T was in a conference in China, but he also had the opportunity to climb and walk the Great Wall of China, one of the world's greatest ancient engineering marvels. So, Mr. T, perhaps as a more lighthearted comment, could you tell us how you felt as an engineer walking on the Great Wall of China?
Amazing. I mean, the wall was built, I think, 2,000 years ago. At that kind of time, the engineering knowledge and technology definitely is not our level we have thought, but even with a modern view of how we construct buildings and looking at how they build buildings, I think, of course, enormous effort have put in, but it's amazing that the way they build it. Climbing it, on the other hand, of course, if I look at today's technology, we're going to do it a lot more humanized, I think. Climbing it, one of the things, I went together with Astray US president, Astray Vietnam president together. My biggest joke is, I wonder how do they get lunch from that station up there? How does the army get lunch every day? You know, it's really tiring to climb, and also some of the steps can be quite dangerous. Okay, but you understand why they built a wall, because climbing within Great Wall is already so difficult. How would the enemy come in from the outside, from the other side? And the design, quite a lot of very practical design element in it.
So there's a lot of ingenuity in ancient engineering there.
Yeah, I think. I mean, sometimes I like to see some of this. Great Wall is one of them. The other one that amazed me, because I deal with water. Right? In the UK, when you go to the bath, the Roman bath, how they bring in hot spring and able to mix the water and control the right temperature in the hot spring, and built by the Romans. I don't know how many years ago. That's another thing. Today we're going to use a thermostatic control and all things. At that time, how do they do it? Yeah.
So, Mr. T, let's go back to the very beginning of the program.
Yeah.
And when I asked you what motivated and inspired you to become an engineer, you said that your family basically brought you to an engineer's inventors fair.
Yeah.
Right? Which brings me nicely to the next question. Let's say I gave you an unlimited budget and 1 year to invent something.
Right.
What would be the first thing that came to your mind?
Right. Okay.
You had 1 year to complete it.
Yeah. Unlimited budget is good, but 1 year is short. Okay. So with 1 year, I wouldn't have time to relearn a new thing. Okay. But in my space, where in the heating energy industry, as I mentioned earlier, heating or thermal energy contributed about 40% of carbon emissions in the world. And that's a great problem to be solved. So we're already in that space, but with unlimited budget, I think we're going to speed up 10, 20 folds and continue to break the limit of energy efficiency. In the heating energy, using a renewable energy to heat, to generate heat, the biggest problem is how high temperature you can go and still be efficient. And everybody is racing towards that. Every researchers are racing towards that. And of course, unlimited budget, we will want to break the limit a lot faster and a lot higher.
All right, engineering thinkers, what an amazing episode we've had for our very first show today. Mr. T's sharing of his case studies and also his advice and tips for young engineers, I hope has been very enriching for all of you. It certainly has been for me. I've learned a lot about how Mr. T manages big projects and all the good work that Intrix does as a group. So obviously, I'd like to thank Mr. T and Intrix for his time joining us here today. I'd also like to thank Group Berhad, who's our media partner and who's hosting our production here today. Without their support, would not be possible. And obviously, Engineering Thinking by IK is brought to you by IK Academy, and you can look us up at ik.academy. Now, I'm going to part with all of you with this very important message. Always remember, engineering thinkers, greater engineer,
greater world. Hi, I'm Tone Vei, the CEO of Intrix Group. We are engineers that design products to fulfill undiscovered needs, particularly in the area of heating, renewable energy, and water purification. To all the engineering thinkers listening, stay rebellious. Always dare to challenge the norm, push beyond engineering limits.
Hello, engineering thinkers. Thank you for joining us in our program today. We'd like to invite you to like, subscribe, hit the notification button, and also follow us on our other platforms such as Buzzsprout, Spotify, and Apple Podcasts. The links for all those will be in the description below. Thank you very much for joining us for this episode, but we have so much more planned for you. So make sure you don't miss out on exciting guests and topics to come. Cheers.